All right, next up is page 83. Okay. So, what we were doing here is it says, in art class, Kennedy draws scale copies of figure A. So A is our pre-image to make a rug. So it starts us off at B. So where do we go from there? Okay, you can just eyeball it. Well, this comes down here, so I'm going to make this come down here. Goes to here. Okay. And you may or not be able to see where to go from here. I'm going to be honest. When I taught this 2 years ago in Ohatchee, my book was different. We didn't do this. We just explored some different things on dilations. Okay. But what it's wanting you to see is you go over, down, over, down, over, up. This is what it should look like. Okay, I couldn't see that. Most of the kids could see it in school, but some of them couldn't tell. What do you mean? Where does it go? Okay, let me tell you how you find that out. And somebody started here. I had to go ask another teacher because it didn't tell me anything except for the center of dilation. But what I could have done is made my quadrant and made the center of dilation or the origin, which a lot of times it is. So once I know this is 0, 0, then I can find my coordinates. So this would be A, B, C, D, E, F, G, and H. I don't have to find every single one. Once I get going, I'll know what I need to do. All right, so A would be -1, -2, -2, -4. So that's A. To find A prime, it tells me my scale factor is 3 to 2, or 3 over 2. That's 1.5. So if I do 3 over 2, 2 goes into 3 one time. So I've got a whole number in there, and it leaves me 1.5. But because I have a 2, I'm going to go -2 over 1 times 3 over 2. -3 times 3, no, -2 times 3 is going to be 6. It's going to be -6. 1 times 2 is 2. 2 goes into -6 3 times. So my new x is 3. Then I do the same with 4. 4 over 1 times 3 over 2 is going to be negative. Are they negative? Nope, it's positive. Positive 4, so that's going to be 12 over 2, so that's going to be 6. It'll be 3, 6. That's not right. Yeah, it is. Okay. So I'm going to find -3. 1, 2, 3, and 1, 2, 3, 4, 5, 6. Here's my A prime. But you already told me that. Okay. Now I'm going to find my H prime. H is 1, 2, 3, 4, 2. -4, 2. Well, look, these are the same numbers. So I know when I multiply, I'm going to get 6 and 3. And I know it's going to be -6, +3. So -6, there's 6. 1, 2, 3, 4, 5, 6, +3. So I know it's going to be here. Now, I wasn't real sure where to do this point, so I'm going to look at this point. 1, 2, 3, 1, 2, 3. So that's -3, 3. I already know, let's see. So -3 over 1 times 3 over 2 is going to be 9 over 2. Wait, let me look at that again. 1, 2. Oh, it's right here. 1, 2, 1, 2. Sorry, that's 2, 2. So 2, 2. It's going to give me -4, -4. So -4, -4. So now I can see where it's going to go in, just like it told me over here. Okay, so now I know that every time I'm going to go in just 1 here, but 2 here. what it's saying, for every 2 squares, I'm going to draw 3. So here's 2, here's 3. Here's 2, here's 3. Here's 2. See, that's what I can't figure out, doing it by the things. So that's why I had to find my coordinates, all right? Here's a little bit easier. It gave me this, so I know that half of 4 is 2. I'm going to go back down and over. Half of 4 is 2, down, over. Half of 4 is 2. Okay, so that's half. Now, I'm going to go to this page. All right, so this says a dilation may change a figure's size. In dilation, corresponding angles are congruent, and corresponding side lengths are related by the same scale factor. All right, so what that means is we've been using this kind of triangle. Okay, if I enlarge that, dilate it, this angle and this angle have to be the same. And look, they are 90 degrees. If I measure this one and this one, these have to be the same. And that little mark means they're the same. These two have to be the same, or it's not similar. Okay? The other thing that has to be this, or has to be proportional, are your side lengths. If this is 4 and this is 6, and my scale factor equals 3, it says right here my corresponding angles are congruent, and my corresponding side lengths are related by the same scale factor. So just like my x and my y, I'm going to multiply my sides by 3 to get my new sides. So remember we learned with our other shapes, okay, this angle corresponds to this one corresponds to this one corresponds to this one. That's why this was so important. So if 4 is multiplied by 3, this side has to be 12 because those correspond. They're the same on each triangle. If this is 6, this has got to be 18. If this wasn't 18, these would not be proportional. So when we look at this, it's saying, first of all of our angles the same? Yes, they're all right angles, so all of them are right. Let's look at our sides. P is our preimage. So P, if I do let's do this right here is width, and up and down is height. So my P, I'm going to do, width over height. So my width of P is 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. Okay, R is 1, 2, 3, 4 over 2. Q is 6 over 2. And then S is, let's do right S over here. 1, 2, 3, 4, 5, 6. Okay, that's the height, so that goes on the bottom. 12 goes on top because that goes across. So if these are all dilations, they should all be proportional. So I should be able to write 12 over 6 equals 8 over 4 equals 4 over 2 equals 6 over 2. Now I really need like denominators to compare them, or I can just simplify. This would be 2. I kind of ran out of room, aren't I? Okay, 6 over 12 equals 2. Because 6 goes into 12 2 times, 4 goes into 8 2 times. So yep, those two are proportional. 2 goes into 4 2 times, so yep, those are proportional. But 2 goes into 6, 3. So this one is not proportional. And that's the Q. And you can kind of see where this one is proportional, this one is, and this one is. Another really cool way to tell is with a straight edge. Okay, this is my center of dilation. I should be able to line up my center of dilation and my corresponding angles. This corresponds to this one and this one. They should form a line. Okay, they did, but what about Q? Q's not on a line, so we know it's not a dilation. So Q did not work, but these two did. So Q is not a dilation, but this one is and this one is. So let's try down here. It's kind of hard because the book's right here. So let's take R and see if it'll go through the points. Yep, goes through R, P, and S. Look, we can try all directions through the corresponding angles. Yep, it hits all of them. Oops. Let's try this one. R to this one. Look, but it doesn't hit R, so R and Q are not dilations. The last page we did was scale factor. So our definition of scale factor could be the number we multiply the X and Y to enlarge or shrink a shape, or to dilate it. We know that if our scale factor is greater than 1, it gets bigger. We know that if it's less than 1, it gets smaller. Okay, figure B is a scale copy of A. So A is our pre-image, this is our image. So we know our scale factor's got to be one of these because it's getting smaller. Okay, the way we find out, I can do height, let's do height over length, so that'd be 2 over 7. Okay, height would be 1 over 3.5. All right, let's see. Or we can do pre-image to image, big to small, 7 over 3.5, 2 over 1. Okay, 1 times 2 equals 2. Does 3 times 5, 3.5 times 2? So what that equals? 2 times 5 is 10, 7. Yep. So if I multiply 3.5 times 2, I get 7. If I multiply 1 times 2, I get 7. So these are proportional. So these are proportional.
At this time, I'll see hand walkers and car riders